hold on.
Catherine.
Her name's Kate.
It's Gabby. I have your Kate.
Catherine and Gabrielle.
Okay.
Everybody has their shorts.
So hopefully Gabby and Kate are getting these well wishes,
Oh my God.
and we hope they return shortly. And Bree brought Gabby shorts.
And
So.
Tony. And Tony.
Tony Tail.
And
Okay.
Tony too.
Tony's here. Objective in heartburn is we should be able to determine if a substance is acidic or basic. We should understand that the pH scale is a representation of how acidic or how basic something is. Alkalinity is another word for basic in terms of acid and bases. We should be able to identify if a solution is acidic or basic based on the pH and understand the purpose of an indicator. And then we're going to move into our lab. So first off, the Arrhenius acids, that's just this, the most specific definition, that's Arrhenius, is they make H plus as their ion, as the cation. So like, whenever you have the ion H plus, that's an Arrhenius acid. So an Arrhenius base, they just have OH minus as their anion. So it's just your ionic compounds. When OH is the anion, you're a base. When H plus is your cation, it's an acid. That's the Arrhenius definition. I'll give you guys a second to copy this one. So moving on, Bronsted-Lowry acids and bases. It extends the definition to include more things. And it's also referring to the acid and base in a reaction, not just a single substance. So things can act acidic or basic that actually don't necessarily fit the Arrhenius definition. This is what we're going to talk about tomorrow. So you don't actually have to record this, what's in the parentheses there. One, the pH scale represents how acidic or basic a solution is. It's a scale that goes from 0 to 14. In the middle of that is pH 7. That means something's neither acidic nor basic. It's what we call a neutral pH. The lower the pH, the more acidic something is. And vice versa, the higher the pH, the more basic the substance is. pHs less than 7 are considered acidic or more acid. And pH greater than 7 is basic. It's more alkaline. If you ever hear the term alkaline, that's just another word for basic, or how basic a solution is. So if I had a pH of 6, is that going to be acidic or basic? What do you think? How about a pH of 11?
Basic.
Good. Okay.
Oh, first.
So moving on. So here's just a diagram with some common substances. Water, pure water is neutral. And then actually the water from the tap tends to be a little bit basic, on the basic side.
Apples are acidic.
Milk is slightly acidic, and your blood is actually a little bit basic.
Ew.
Fruits and things with citric acid and different acids tend to be acidic. Lemon has a pH of 2. It's very acidic. 1 molar hydrochloric acid has a pH of 0. Things that are basic, like baking soda. I know Guy said that sometimes you can take baking soda to help your heartburn. They're basic because they react with the acids. Soap, ammonia, which is a cleaning product, and drain cleaner, which is sodium hydroxide, which we're going to be working with today, is very basic.
Oh, so you can drink drain cleaner?
No, you can't. That's a strong base, and if you drink drain cleaner, your throat will probably close.
Oh my goodness, Tony, don't do it, don't do it,
Don't do it, Tony. Don't do it, Tony.
No. You should never, ever ingest chemicals that aren't meant for ingestion. Yep.
But nothing can stop the claw.
Nothing can stop the claw.
Listen up, guys. Stop. Okay. Here's some more stuff. Detergents. Kimchi. If anyone likes kimchi, I like kimchi. Kimchi is I think it's a Korean-style pickled cabbage.
Was the president in Korea?
Nope.
Kim Jong.
That's Kim Jong-un. Okay. Indicators, and this is what we're going to be doing in our lab today. Indicators are substances that have different colors at different pHs. So, for instance, bromophenol blue, at pH 3 it's a yellowish color, pH 4 it's purple, pH 5 it's a dark purple. Or this is more pink, I guess, pH 4. So if you were testing, if you needed to test a solution between 3 and 5 and you needed to know those differences, bromophenol blue is a good indicator. It's not a good indicator if you need to test the pH between 5, 6, 7, because it's the same color there. You'd use a different indicator, maybe a universal indicator, to test that difference, because universal indicator, at pH 5 it's an orange color, at pH 6 it's yellow, and pH 7 it's green. So that's a better indicator. Now what you're testing the pH range for, should determine what indicator you want to use. Azurin red, or resazurin, is a good acidic indicator because it has different colors in the acid range. But as you get to above pH 7, it has the same color. So they're pretty cool. There's lots of different indicators, and we're going to be working with some today. In fact, cabbage juice is an indicator. We're going to use that today.
Wait, you're going to use...
Cabbage juice is a pH indicator. If you guys, spring's coming up, and hopefully by May and June, you guys will notice the hydrangea flowers. Hydrangea flowers are a pH indicator of the soil. The soil has a pH, and it depends. The color of the flower depends on the pH of the soil. So in an acidic soil, a pH of about 4, between 4 and 5, you're going to have a very blue color hydrangea. And if you get more neutral, it's a pink color, and in between, it's a purplish color. So you can have this whole range of soil pH, and that will determine the color of the flower. So because there's an indicator in there, and you can actually change that color. I think I've seen landscapers will grow it in 2 separate soils, the same plant, and it's divided, and you can actually have that'll indicate what color it is based on where the roots are coming from. Yep. Oh yeah.
We have like these stuff that we put on it, and it's like make it blue.
Yep. Yeah. So landscapers, they can change the color of the flower. It's pretty interesting. So that's it. Let's get started on our